This video is part of our academic project titled Adaptive Image Detection and Chatbot System. In this video, we will be discussing about the project, the existing system, our proposed system, and our demonstration as well. So in this project, we are proposing a modular framework that combines object detection model, image captioning model, and a large language model. So what are we proposing? We can find many models that are unified into a singular architecture, which can be very complex, and we need to retrain the model if we want to enhance the capabilities, right? So we are proposing a flexible model, a flexible framework that combines all the three models and which we can replace as well. That is why we call it adaptive image detection and chatbot system, right? So for image captioning, we are using blip model. For object detection, we are using YOLO 11, both trained on Coco dataset, and the LLM Gemini. So existing system, as I mentioned earlier, have direct image to text, and also the models like FuseCap, which enhances the image captions using LLMs. So we propose modular framework that combines all the three models into a singular one, which is flexible and plug and play. So let's jump into the demonstration. This is our code. We are using Streamlit for the front end and Gemini model. So first we load the environmental variable where we have stored our Gemini API, right? We load it and we configure it. We are choosing Gemini 1.5 Flash for this project. We are storing chat history as session state memory and image context as session state as well. So there we go. We have loaded the image captioning model and the object detection model as well. So what we do here is the detected objects will be separated from the bounding box information. What we want is only the class names. If you want, you can use the bounding box information as well, but we don't require it, right? So we structure the results from the object detection model and the image captioning model in this way and feed it into the Gemini model so that it can generate a detailed description. Now, the detailed description is not our final output. It is used to generate responses tailored to the user queries, right? So here the image is uploaded, image is analyzed, and user after the user queries, the bot generates a response based on the user query and the detailed description. So let's see how it works, right? Okay. So as you can see, this is a very simple chatbot interface. Here we can browse files and we will be uploading an image. Okay. So as you can see, we have uploaded the image. So let's just type a simple query. What is the man doing in the image? Okay. Right. So as you can see, the bot responds. He's skateboarding and it looks like he has a dog with him, right? So cool. Now let's ask something else. How many cars do you see in the image? Right, it says based on the image description, there are at least two cars visible in the background. Yes, so we can see yes. Right. So this is how we query and the bot responds using the detailed description that is being generated by the Gemini, right? As we had discussed, this is how our project works. Three different models, totally separate, not a unified architecture, very flexible. Now, if we want to replace the YOLO 11 model with a newer version like YOLO 12, we can do it very easily, right? In unified architecture, what we had to do is we have to retrain the entire model, entire architecture, which is very complex and which is very computationally intensive. So this way, we can do it in a simpler way, right? Our goal you, for this project was not to replace any existing system, but to provide an alternative to test newer versions of models, how it works cohesively in production level systems, right? So thank you.